All right. Hello, everyone. Welcome to our stream on RAG and particularly re-ranking. As you can see, I'm a big fan of alliteration, so I've titled this talk "Real RAG Re-ranking" with Haystack and Milvus. So for this presentation, we'll be hearing from Tuana Celik from deepset and their new release of Haystack. If you are in the stream, I'd love to know where you're checking in from. So please drop a comment below. Let us know where you're coming from. And first, we're going to start off with just an introduction into Haystack and Milvus. And then we'll get into the actual tech part of it, where we'll talk about how you can use these technologies to do RAG. Okay, so before we do anything, Tuana, why don't you introduce yourself?
Yes, hi everyone. Can you hear me properly? Let me know if I should switch to another mic, but hi everyone. I'm Tuana and I work in the DevRel team here at deepset. My primary focus is Haystack, which is our open source AI framework, which I'll tell you all about in a bit. But yeah, that's me. I'm based in Amsterdam, so it's the end of my day, but I can tell that it's probably the beginning of the day for most of you in this call.
Yeah, it is 9 a.m. here. It looks like we have got 2 people who have checked in from the Bay Area, so it looks like there's also 9 a.m. for them. I don't know if we have anyone else checking in from the East Coast or any other. 3 people checking in from the Bay Area. We got San Jose and 2 in SF, so a lot of Bay Area participants. So I'm going to first introduce a little bit about Milvus. We're just going to talk about Milvus very briefly. I think many of you who attend this have probably heard me talk about Milvus before, so I will be kind of quick about it. If you have any questions that you want me to answer specifically, please feel free to drop it in the chat and I will address that. And then once I cover that, I'm going to pass over to Tuana. She's going to talk to you about Haystack 2.0. And then we're going to get into the RAG portion. So first, let me do this. Add to stage. Okay. So we're going to take a look at Milvus. So Milvus is a production-grade, enterprise-ready vector database, and the things that make it so are primarily the ability to scale horizontally, this auto-scaling feature, a loosely coupled or mostly decoupled system, which allows you to have both write and read consistency at scale, as well as separate them as you scale your different use cases of write and read, and also enterprise ready features such as role-based access control, and a separation of concerns like the querying, the data, and the indexing. So this is a high-level overview of Milvus' architecture, and it just shows you that you can, that as data comes in, it goes into the message store, which is modeled as a pub sub system. And so there, the message store you publish events to, and then the worker nodes will be able to subscribe to the message store to get these, to get the data as it comes in. And the worker nodes are all stateless nodes. They get spun up and down based on a stateful coordinator service. And that coordinator service is run by etcd, and then all of the vectors get stored into permanent storage and min.io. On top of this stuff, there's also a lot of things that go into vector search at scale that you might not consider immediately that are quite important. And some of those things include the way you index your data, the similarity metrics you use, and the way that you filter on your data. So the way that you index your data, there are many, many indexing options. There's HNSW, which is hierarchical navigable small worlds, which is an indexing option that is very, very memory heavy, but gives you very good search and also is rather fast. And then there's things like IVF, which is not as memory heavy, but gives you, once again, rather good results, not quite as fast and a little bit more compute heavy than HNSW. And then there's things like quantization or flat options or things like that. And those things have specific use cases. So for example, if you need 100% recall, 100% accuracy, you would use something like flat. And if you need something that really, really condenses the amount of memory that you're going to hold, you're going to use some sort of quantization option. And then there's also similarity metrics. So there's things like cosine similarity in our product, Euclidean similarity, and all of these things actually measure different similarities. And they are used in different use cases based on whether or not your data is normalized, based on the type of embeddings model you use, and things like that. So this is just a little bit about Milvus. Now I'm going to pass it over to Tuana to give an introduction on Haystack 2.0, which was released rather recently.
Yes, let me hopefully try share my screen successfully. All right.
Oh, we have
me know.
Yes. Here it is.
Okay, great. All right, so I changed this presentation just before this call after a quick chat with Yujian. So I'm not only going to talk about re-ranking, but I've heard that there's some questions about Haystack 2.0. So it also includes some introduction into Haystack 2.0, how it's changed from 1.x briefly, and what you can build with it. And then we also have a public repository for you to try out re-ranking with both Haystack and Milvus. So I'll also change to that screen later. Maybe we can do a bit of live coding as well. All right, so quickly about Haystack, and specifically Haystack 2.0. So Haystack, for anyone who doesn't know, it's a fully open source framework, all built in Python. And the main idea behind Haystack is allowing people to build custom AI applications, specifically around large language models. And the idea behind Haystack is to provide a bunch of tooling for developers. But one thing that's significantly changed with, in a way, the ethos of the framework is that it's meant to be very much extendable by any developer who wants to use Haystack. The main building blocks are pipelines and components. And I've added here a small, just like a infograph of what that might look like. So with Haystack 1.x, we had a lot of experience in building NLP pipelines. And I'm sure you've heard this recently within the Gen AI community, but it very quickly starts to look like a graph. So the main difference with Haystack 2.0 is that the graph became a lot more flexible and a lot more powerful. So we've noticed that effectively an AI application requires on multiple components working together. That might be a retriever, it might be a re-ranker, it might be a large language model, and each of those components play a role, and they're funneling down data from one component to the other. So Haystack pipelines can now branch, which is great because that means you can have decision nodes. They can loop, which is great because you can have effectively services that loop until a certain condition is met, and so on. So Haystack 2.0 went live last month. I think it was exactly the 11th of March. If you want to learn more about it, I've added this QR code here. Yujian had a bit of a laugh, but the QR code is in all of the next slides. You can read about the release, what it meant for us, why we made it. All of that is available right now. All right, so a very classic pipeline that we're seeing people build, obviously, is RAG. So what does that look like in Haystack? So Haystack, like I said, is made up of components, and every component can be attached to each other to build out a full pipeline, depending on what your use case is. This particular pipeline that you're seeing here is a classic RAG pipeline. You have a user enter a query, and that is embedded. We call that an embedder doing that, and that embedder can use many a model provider. Following that, we use that embedding representation to retrieve some context, and that can retrieve that context, for example, from Milvus. And then we want to actually prompt a large language model based on some sort of instruction, including the retrieved context. And again, we might use any of these given model providers to actually generate the response. Now, what is re-ranking? So re-ranking often comes after the retrieval step. And it's mainly around increasing the relevance and making sure that there's no duplicate data within the retrieved context. I stole this image completely from Gina AI, credits to them. And what I'm going to show you in the coding section of this talk is going to be with the newly released Gina re-rankers as well. And I think this is a pretty good depiction of what's happening with re-ranking. You might have a bunch of documents, and then you might have a query, and based on that query, we're returning relevant documents. But then re-ranker can further bring down the number of documents or the relevant documents, make sure there's no duplication going on. And we're going to see a use case of this. I thought this was very, very clever of them to do. I'm also using the demo use case as well. They chose the example of Jira tickets. So let's say you're creating a new Jira ticket, but obviously you don't have any idea of all of the other Jira tickets that may have been created before. How can you see if what you're creating is relevant to already existing tickets or not? So we're going to have a look at an application that does just that. We're going to pretend to create a Jira ticket, and then we're going to get back responses from relevant Jira tickets, and we're going to make sure that they're actually very relevant to the ticket that we created. And we'll be able to make sure that we don't repeat. And how does that look in the context of Haystack? Well, like I said, it's often right after the retriever. We can add a re-ranker component. We have a few already. The Gina re-ranker is one of them. All right, so this is where the presentation has slightly changed because I wanted to give a bit of an intro to Haystack 2.0. One of the main things that has changed with Haystack 2.0, in my opinion, and I've been using Haystack 2.0 a lot, I use this functionality very frequently, is the fact that, so I've been talking about components and pipelines, and every component is effectively a node in a larger graph. And what's nice is any component in Haystack, whether that is a retriever, that is a embedder, it could be an LLM, anything, we have completely unified what the interface looks like. So everything is a component. And this right here, what you're looking at might be a component, right? There is just like this node that is accepting 2 inputs and is returning 1 output. How many inputs that is and what the outputs are is completely up to you. So this could be a very simple way of building a retrieval pipeline. I have one component that is taking in a sentence and is outputting some sort of embedding, and followed by another component that is expecting an embedding that's outputting a document. And that's it. But it's all very flexible. It's up to you to decide. If you do go ahead and start using Haystack, and let's say you do not have, I don't know, the exact component you want. I'm going to show you one example that I built actually. You're free to build your own component, and that component can have as many inputs you need and as many outputs you need. And then you also can decide how exactly those components interact with each other. I hope this starts to make sense slowly, but here's a component that I built for a demo. That QR code should take you either to the collab or the live demo on Hugging Face, because I put it on Hugging Face. The idea was that we wanted to build a RAG pipeline. It's not actually RAG because we're not properly doing retrieval in this case. But I wanted to build something where, given a number, top K, it returns that many trending articles from Hacker News. And then I wanted to build a pipeline where all of those articles are summarized, and also we get references to the links where the articles live. So basically, this is what I wanted to do. I wanted to have a Hacker News fetcher, followed by, in the Haystack world, we call it a prompt builder, followed by a generator, generating some sort of summarization. So how do we build that in Haystack? So this is what I mean by a unified interface. Everything is now a component. You just need the component decorator. This is very fun, I know. I just called it my custom component. But what's important here is that I have the component decorator, that I have a run function, and I have component.output types. This is only used for pipeline validation. So basically, I'm telling the pipeline, wherever this component is used, it's expecting a query and it's returning documents. And this here is only returning hi and bye, so it's not really doing much. And it works. So if you like, you can check this out. This was, I don't remember when I tried this, but this is, I'm asking for like the top trending post on Hacker News whenever this was, and it's telling you a bit about the article, and it's also giving you a link. It's a link to a repository. And you can also check that out in this collab. One other thing that's changed with Haystack 2.0 is, and this is an example of a looping pipeline. So because I hope it was clear that outputs can be as many outputs as you like, but we can also have optional inputs to components as well. So this is another example that we built where we're actually validating structured output and we're letting the pipeline loop until it's actually generated the correct structured output that we need. And the way we did this was by providing a Pydantic model saying this is the Pydantic definition you should abide by. We built our own custom output validator component, which told us whether it was valid according to our Pydantic model or not. And if not, it was able to return both the invalid reply and the error messages that we got. And this continued until, hopefully, we get a valid reply. The good news about this, you can set the total number of maximum loops that you allow. So you can also say, you know, don't do this more than 5 times. This makes sure that you're not necessarily querying OpenAI and racking up a bill. So you can set some guardrails around that. So that is Haystack 2.0. I think I'm going to stop sharing because I need to now find the, I should find the code example. And maybe you can explain exactly what's going on with the Milvus setup as well.
Let's also take some questions here.
Yeah.
Difference between Haystack and LangChain.
Okay, I get this question quite a bit. I would say the main difference between Haystack and LangChain, they are obviously solving pretty much similar problems with a different approach to the developer experience and a different approach to how the framework is built out. So I think the developer experience is the main difference here. Haystack has a lot more of a graph structure and it's a lot more centered around customizing components. It does make it a bit more verbose to use than LangChain, and you'll see exactly why. But from my experience, it also makes it a lot more easier to severely customize and make sure that you're building the exact application that you want. So that's my slightly political answer to that question. I hope it made sense.
As you're pulling up this code, let's also look at this question. If context size for LLMs are increased, will it make Haystack redundant? And as you're pulling up your code, why don't you pull up your code? And I'll answer this question about Milvus, since I get this question about vector databases all the time. If context size for LLMs, people ask me all the time if context size for LLMs are increased, will it make vector databases redundant? And the answer is probably not, because it's going to cost you a lot of money to do that. Cost and efficiency are always very important when it comes to running anything in business. How would you answer this question, Tuana?
I would probably answer pretty much the same. I feel like context sizes increasing is great for one-pass solutions, but I don't think that it really negates the fact that you probably want to have an application that is communicating with various different services and pulling in data from various different services. You still have to orchestrate something. So from Haystack terms, the fact that you have to build out an architecture as to how you want your application to behave, I don't think that's going away with context size increasing. If you see what I mean, you still have to fill that context with something that might be coming from an API, it might be coming from Milvus, and so on. Yeah, I hope that made sense.
Great, thank you. And before we get into this code demo, can you zoom in a little bit?
Oh yeah, let me do that. Does that help?
I think that's much better, yes. Okay,
so I can start talking about this if you like. Maybe you can also, I don't need this. Let's say bye to this. is completely available. I've made it a GitHub repo. It's open. I'm going to be running through the Python notebook because I think it's just easier to run through in a live stream. But I've also provided the same steps as scripts called indexing.py and Jira ticket query.py. I saw someone make fun of how fun a Jira ticket example is. I totally agree. I was just being a bit lazy, honestly. I think it's a great example from the Gina AI folks. So I'm just going to run through it. But the idea here is maybe I should just quickly run through what kind of data we have. This is, I don't remember the project, actually. I should have written it down. This is a JSON file with all of this project's Jira tickets. You're right, it's pretty boring. But the idea behind it is we want to have like a system where if I, for example, enter a new ticket, I get some idea as to what other tickets are there that are maybe duplicates. Do I actually want to create this, or do I want to comment on something, and so on. So I wanted to do this with Milvus for obvious reasons. I'm not going to restart Milvus or do the indexing pipeline because I already have the tickets in there. I don't want to do it again, but I'm going to run you through the indexing pipeline. And actually, for the people who asked about, I think there were some questions around the graph structure and difference to LangChain, you'll see how the syntax is pretty different. So just to check, if I say document store.filter documents, you're getting all of these documents. This document is the Haystack document type. It comes with content as well as, if you want to, add metadata to it and so on. You'll see how we've done that. And I have a Milvus document store, a Dockerized Milvus document store running. I've just simply connected to it. And I'm going to show you how I've written documents into it. So this is our first example of a custom component. In our use case, we have a bunch of tickets with probably quite irrelevant fields in it. I don't want to use all of the fields in this JSON object. So the first thing we do is we create a custom component called remove keys, which I can give it a file name. I can give it some relevant keys, and I'm making sure that I'm only keeping the relevant keys. I could probably severely reduce this as well. So we're already keeping, I think it starts with comment and then goes up to comment 15. So 16 comments, probably don't need that much, but this is up for you to decide. You can play around with this. The next thing we do is create yet another custom component, which is a JSON converter. Haystack 1.x had a JSON converter. It's coming. We don't have it right now, so we actually had to add this as well. And it's simply describing what we want our documents that we're going to be indexing into our Milvus document store to look like. So here we're defining what it is that we're adding into metadata. We're adding issue key, issue ID, and parent ID. And that's it. And this is where you get the indexing pipeline. So for this case, I am also using the Gina document embedder. And I'm calling my remove keys cleaner. I'm calling my converter. I've got an embedder and I've got a writer. And this writer is going to be the one that's actually writing those documents into my Milvus document store. And this is where it gets pretty verbose, but it's also very, very powerful. If you want to, later on, I can show you a pretty complex pipeline that does looping. But what I've done is I've added the exact components I want. And here, and this is where it can get quite crazy, I've defined exactly how I want those components to interact with each other. So I'm basically saying, cleaner, whatever you're returning, you have to give that to the converter. Converter, whatever you're returning, I have to give that to the embedder to the writer. That's it. What I could do, and we can see some examples later, let's say I'm making this up. Let's say the converter had 2 outputs. I could have said converter dot output 1 go to the embedder, converter dot output 2 go to the writer, for example. In that case, I would maybe not be using the embedder. So this is just an example of how we build Haystack pipelines. Now, this is where I hope that my Gina API key is still live, so I don't have to pull it in here. But let's start looking at the pipeline that we build with the actual Reranker. So this is, again, something I stole from the Gina AI announcement article. We create yet another we create yet another component. So off the bat, we make the decision that maybe if Jira tickets have parent tickets, oh my God, I used to use Jira. I'm saying Jira way too much. I really hated it, but I guess I'm just going to have to go through it. If the Jira ticket has parents, maybe we shouldn't bother about it. It's very clear that there's a parent ticket, etc. So this is what we're saying is called remove related. And actually, I've called it parent cleaner in my pipeline. Next thing I'm going to be doing is I'm using the Milvus embedding retriever. That's telling Milvus that there's going to be an embedding representation of a query or something like that, and that it should be retrieving the most relevant documents. I'm using as my text embedder, I'm using, again, the Gina text embedder. And then I'm using the Gina ranker. Now what I'm doing here is I'm adding those to my pipeline. I am then saying the embeddings from my query embedder is going to be handed as the query embedding to my doc retriever. And then the doc retriever is going to go to parent cleaner, and then parent cleaner is going to go to Gina Reranker. And if I do that, okay, great, it's actually working. And on top of that, I'm not sure if this works in VS Code. Let me try something. This definitely works in Colab. But one cool thing that you can do, so you can, let's see, does it? Oh yeah, there you go. You can also show the exact structure of your pipeline. This is very handy if you want to, if you're building quite a complex pipeline with loops in it, lots of branching, etc. But you can very clearly see what component is being provided, what component output is being provided to the next, and so on. It's kind of like a sanity check. If there's something going weird with your pipeline, you can just hit show, and yeah, you can just have a look at what's going on. So what we've done here is I've faked it in this case. I don't want to create a full Jira ticket, to be very honest with you. So I'm using one of the ones that are already available in the tickets.json that we have here. And if I run that, I'm getting all of the relevant documents here. As you can see, there are 10. So this, as a ticket, I know I had a look. It's about making documentation a bit better, improving docs, extending docs, and so on. But the cool thing here is if I were to, let's try and make sure that we're doing this right. Let's take out the Gina Reranker. So I'm not adding it to my pipeline. And let's just call it, it's just removing the parent documents. Let's rerun this. I hope I've done the right thing. Yeah, okay, so let's just make sure here as well. Yeah, okay, so I'm not re-ranking anything. Fingers crossed. I hate live coding sessions. What did I do? Oh yeah, Gina, I need to take out this input too. Can I do this? Hopefully. Nope, where are you? Gina. Oh yeah, let's do this. What is the document cleaner? Outputting documents. Okay, let's do this instead. Okay, and as you can see, that's 9 more documents, and there are pretty irrelevant stuff in here. If you're really interested, you can try to read through them, but they're pretty irrelevant to, even with embedding retrieval, they can be quite irrelevant to what the actual question was. The reason for that is, for the retriever, we said you should return the top 20, or I think it must have been top 19 or something like that. So by default, it's aiming to return that many documents. By adding the re-ranker, we're significantly reducing the number of documents it has to return. And there we are. Again, this is completely free for you to try out. I think, Yujian, did you send over the GitHub repository?
Yes, the GitHub repository is in the comments, I guess, chat, something like that.
Yeah. Okay.
There's also a question here for you. Can we build any shaped pipeline so long as it's a directed acyclic graph with one terminal node? Oh, so. Yes.
And actually, the cool thing is I'm hoping that I'm getting the technicalities here correct. But technically, Haystack 1.x, 1.0, whatever you want to call it, was a directed acyclic graph. But Haystack 2.0 is actually a lot more powerful simply because the directed part has actually been dropped. And the reason I say that is you can actually implement loops in this scenario. And that's exactly how we built the output validator. If you like, I think we have quite a lot of time. I can show you an example of how we implement those loops. And that's where the pipelines become a lot more powerful, from being just single directional to themselves becoming sort of like this agentic service that you can provide. So if you like, I can show that.
I think, if you want to show that as part of your presentation, that makes sense to do.
Okay, let me try and get it up.
That probably drops the acyclic piece. If you can create loops, you can create cycles.
Yeah. Yes, exactly. Yeah. Yes.
Directed graph.
Where is it? Let's do
brilliant
tutorials, and let me bring up the. Let me actually send this. Can I write in this chat too, Eugene?
Yes.
It says join chat. I'm just worried it's going to ask me to sign up and then I drop off or something.
Oh, I think you can just send it in this chat. If you can't.
Oh, yeah, no, I cannot because I need to sign in with YouTube. But maybe you can send over this to people.
Yeah, just send it to me and I can send it to the chat. There we go. There you go, chat. And then I'll put it in the LinkedIn chat too. I'll mute myself.
Okay, I'm going to start sharing this. This time I'm sharing my whole tab so I can easily navigate through. Yeah, can you maybe get my screen up? Okay, so I'm just going to walk through this because what we're going to be achieving in this particular tutorial is actually this loop. So I'm going to show you how we created the output validator. I'll very briefly go through that, but the main interesting part here is how the output validator is deciding whether it should send information back to the prompt builder, basically the LLM, and say, nope, you got it wrong, try again. And how, if it is valid, it can end the loop. So what's happening here is another thing that's significantly changed in Haystack 2.0 is how we build prompts. I didn't really cover that, but we use Ginger templating. Very quickly, this is the Pydantic schema we decided to have for this demonstration. So we've got cities data, which is a list of cities. Every city has a name, country, and a population. And then again, the output validator is simply a custom component. And this uses Pydantic to say, here's the reply you got from the LLM. Check if it abides by your Pydantic schema. And if not, I am returning both invalid replies and the error message. I did not build this tutorial, but I think this is actually quite genius because you're not only saying you got invalid replies, you're also giving it the error message that Pydantic gave you. Which hopefully the LLM can actually use to retry and fix the structured output. But the main magic here is happening in this particular part. So I'm creating a prompt template. This is all Ginger. And I'm saying, create a JSON object from the information present in these passages, only use information present in these passages, and it should be abiding by the schema. All of that is fine. But the main difference here is this if statement. So each of these things in curly brackets automatically become inputs to my prompt builder. But as you can see, there are these inputs that are in an if statement. So this section of my prompt is only going to be added in if I get invalid replies and error messages from somewhere. And then let's scroll. All of this is quite uninteresting, but let's scroll down to how we actually connect the components. So I'm giving my prompt to the large language model. The large language model is generating some structured output and giving it over to my output validator. And then the output validator, if it gets invalid replies and an error message, that's where we can be very specific, is being added to the invalid replies and error message in my prompt. And then if not, let's scroll down, I can simply print out the output validator's valid replies. And there we are. So this is where I feel like the custom components and the way building components has been very much unified. And on top of that, how these pipelines can be very much structured to your exact need. And that they're very, very, yes, they're verbose, but they're very specific and customizable in how they actually interact with each other, how each component interacts with each other. And I would say that's probably one of the main differences between Haystack 1 and Haystack 2. And there we are.
Great. I think we also have some questions about some of this stuff. So someone says, is it the same as regex? So I don't know. This was asked like a couple minutes ago. How about, okay, you know what? Let's answer first. Yes. So Viba, if you want to expand on what that question is about, that would be helpful. But he's also asked, what does the output validator use behind those libraries?
Okay, so our particular output validator, I'm sure you can build your own that does different things or just implements it in a completely different way. Our output validator was simply meant to validate JSON structure, and we wanted it to abide by the JSON structure we wanted, and it's using Pydantic. And that's it. That's really it. But I'm sure you can build others that validate other things. Like I said, building components is completely up to you. You only have to have a class with a component decorator, and you only have to have a run function with a clear definition of what the outputs are. That is all.
Okay, so here's the question: was the parsing JSON object, is that done using regex?
No. Again, Pydantic.
Yeah, you just answer that question. That's done.
Pydantic is great. It's a whole library meant for this purpose of validating JSON. So yeah, that's what we used. I think in our use case, picking this was very easy because we said, okay, but let's try this use case with JSON. But I'm pretty sure you can try and do the same with other types of things as well. So for example, the other day I built a SQL chatbot, and technically I don't have proper output validation. I'm just trying the SQL query that the LLM is generating, but I have added something called the conditional router that is checking whether the query actually has anything to do with my SQL table, and I'm not querying it if the question was just completely unrelated to what I have in the table.
Yes, and we have another question. Is Haystack vector store agnostic? I'm going to take this as, and are there advantages to leveraging Milvus? So I think this is a two-part question, but I think Haystack is vector store agnostic. Is that right, Tuana?
Yeah, I think maybe I'll answer the first bit and you can answer the second bit. Yes, Haystack is vector store agnostic. Milvus is one of them. We'd love to have Zilliz support, Yujian, just let him know. But you can decide Weaviate, Quadrant, Pinecone, MongoDB. A lot of them are available. Yes.
So I will answer the second part question: is, are there advantages to leveraging Milvus? And like I said at the beginning, it really it's going to depend on your use case. Or I guess maybe I didn't say this at the beginning of this particular stream, but I say this all the time when people ask me about vector databases. Is it's going to depend on your use case. If you need something that's going to be client-side, Milvus is not going to be for you. If you need something that's going to be something like, available in multiple regions and something that you can scale horizontally very easily, if you want to customize the indexes, if you want to customize the metrics, that's when you would use something like Milvus. So for example, if you want to use cosine, IP, L2 distance metrics, and you want to test them out and compare them, that's when you would use something like Milvus. If you want to compare how your vector retrieval differs using HNSW or IVF or some other sort of retrieval or some other sort of index, that's when you would use something like Milvus. Otherwise, I think they're all very similar. So I think this is a comment, but I think this is a question about whether or not there's a way.
Every LLM does the same.
Each token costs.
I love this type of experiment. Maybe I can give you, this was not my idea. It came completely from my colleague Billier, so I'm not taking credit for that. But this is actually a good one to bring up because just yesterday I tried to use the output validator with a completely different model, doing something completely different. For all transparency, I was trying to build something called Swifty structure, where you can give articles about the new Taylor Swift album release, and it gives you a structured output on the songs, who they're about, what they're about, and so on. And I was using Llama 3 with Olama. Didn't work so well. So yeah, I'm very interested to run this type of experiment. I think there's a lot to say about how you prompt a model. Not every model is expecting to receive information the same way. So I think there's a lot to say about experimenting with how you instruct models. And you're right, experimenting on exactly how much, like what the cost would be given a model. I definitely went through more loops with Llama 3 yesterday than I did with the example I showed you here. I think it uses GPT-4 actually. I'm all down for that type of experimentation. I will let you know if I run something with the same exact prompt, the same exact everything, maybe with different models.
I have a follow-up question to this. Is there a way to track like token costs and like number of tokens used in Haystack, or even in any of the other frameworks, if you know?
Not as a provided sort of structured maybe data class, but I know that the team is looking into that sort of thing, especially alongside tracing and evaluation and all that sort of debugging metrics. Obviously, you can extract that information yourself, but we don't yet provide a data structure that's going to make it quite transparent to you without any work on your end.
Okay. Yeah, I figured that actually be kind of tough because there's like a lot of different like tokenization models for each of the LLMs. And actually like something that I was working on, and I don't know if you've run into this as well, is just like the LLMs themselves have different tokenization structures. Like some LLMs will tokenize numbers as one token, and some of them will tokenize them as like 2 tokens. And then you're like, wait, what's going on here? I thought this was using like, like 50 tokens, and it's actually using like 60 or something like that. Oh, someone has a comment about this. Apparently you can track token costs.
Oh, that's nice. I did not know that.
Yes. Okay. I have also not tried that. Is Langsmith, that's observability, right? Do you guys have an integration for that?
We don't have an integration for Langsmith, but what we have recently done, and I think that's actually answering the next question that came in. Oh, wait, maybe. Oh, yeah, that is the one. There's another one that came in. Yeah.
Tackling.
Yes, which is maybe only one part of observability if we want to be very technical about it. Okay. But one thing that we're adding is a lot of tracing support. So actually, one thing that I didn't mention, our ethos for Haystack 2.0 was not only about unifying the interface of component creation, but it was also about doing that across the board for, I would say, all functionalities. So document stores, they all share the same interface. It's very easy to bring in your own document store. And the same goes, I'm not sure if there's going to be many people in this live stream that care about this, but the ones that do would, is all about serialization. So when I say serialization, I mean you can represent off the bat, you can represent Haystack pipelines as YAML. So that's already something that we provide. But we've made the serialization part extensible. So there's a unified way where you can say, oh, I have all of my config files defined in TOML. I don't know, I'm making this up. You can bring your own serializer. It's literally 4 lines of code and represent all your Haystack pipelines as TOML. We tried it with message pack, works well. And on top of that, one other thing that's been unified is tracing. So implementing your own tracer. OpenTelemetry is supported out the box. You can bring Datadog in with that, and you can bring your own tracers. You just have to implement your own tracer. So I know that's technically only one specific part of a larger observability ecosystem, maybe, but yeah, I think that's something that we're really keen on continuing to implement.
Next question. Can you? Oh no, this is not even a question. This is just a comment. I didn't even read this until I put it up. But basically, like, I think this person's just talking about the LLM provider stuff that you can track that based on the model output and stuff. Yes,
yeah.
Also output the metadata and stuff like that. Unfortunately, it's not the same model to model. That's what I'm complaining about. But what can you do? Cool. So we're coming up on about 45 minutes here. I know there's like 50 some people watching on LinkedIn. So if you have comments from the LinkedIn side, you guys feel free to drop any questions as well. And then I think we'll keep the stream open for a couple more minutes for questions. Otherwise, I think we can call it a day.
Nice. We should build something together next time.
Yes, yeah. We should build like build some sort of. I should contribute to some sort of like Haystack app. That's what I should do.
Bring Zilliz.
Yes, get the Zilliz integration. I think the Zilliz integration and the Milvus thing should actually be the same. You can probably just like use.
Maybe.
I guess I should just test this out. I should just take your code and like test this out with like a Zilliz endpoint. Okay, I think we've given people enough time to type in some questions here, and I don't see any questions being typed in. So thank you guys all for coming to this workshop, to this webinar. Thank you, Tuana, for doing this webinar with me and for doing the live code. That's always very fun to do. I'm glad things worked.
Yes.
I had this one. I had this one webinar a while ago where like I ran into this error in the middle that I didn't know how to fix because it was dependent on like an external library, and I was like, oh god. So
yeah, I know it's a bit nerve-wracking.
Yeah, I can always be a bit nerve-wracking. So thank you guys.
Just a reminder to everyone that repository that I shared, if you have Milvus running, there's indexing.py that you can run, and it indexes documents ready to be used by Haystack. So you're all set.
Cool. And I will share the links in the post-event email as well. So yeah, nice. Thank you everyone for coming. Thank you for coming on, Tuana, and we're going to end the stream.
All right. Thank you for having me.